Welcome back. We now have the town hall session on superbugs versus superdrugs, the looming global drug resistance crisis. The panelists for this session are Dr. Victor Nizet, Professor, University of California. Sir, please. Dr. M.D. Nair, Consultant, Indian Pharmaceutical Industry. Dr. Anirban Banerjee, Assistant Professor, IIT Bombay. Dr. Anand Kumar, CEO, Bugworks. And Dr. Jeff Perry, Assistant Professor, University of California, Riverside. The session will be hosted by Dr. Bipin Nair, Amrita School of Biotechnology, and co-hosted by Dr. Anand Kumar. Over to you, sir.
So welcome to this town hall meeting, as we call it, a panel discussion on what we decided to call it super bugs versus super drugs, the drug resistance crisis, and are we ready? As Professor Nizet alluded to in his inaugural address, over the past decade, a common news headline that one has very frequently seen is superbugs could kill 10 million people a year by the year 2050. Another BBC report stated that superbugs will kill someone every 3 seconds by the year 2050, unless the world acts now. Our problem has been that remedial action has been slow to emerge or is almost non-existent. And the overuse and or misuse of antibiotics, as well as the lack of new drug development by the pharma industry due to reduced economic incentives and challenging regulatory requirements has been mainly implicated in leading to this crisis. The fear then is that the unchecked growth of microbial resistance may hasten the end of the antibiotics era without the option of an effective substitute for these wonder drugs. In a sense, even trivial infections may turn deadly because of the lack of curative treatments. Here in India, the scenario in this regard is also extremely complex, with several drug-resistant microbes having been identified in operation theaters and intensive care units in all major hospitals across the country. Unfortunately, India also has the dubious distinction of having the first ever scientifically proven discovery of a drug-tolerant microbe named NDM1, the New Delhi beta-lactamase 1. So to address some of these questions and take advantage of the experts that are here for this symposium, we wanted to look at several aspects of this crisis and try to understand the what, why, when, how of drug resistance. Take a look at the Indian versus the global scenario. What are the effects of this drug resistance crisis, on the clinical and economic burdens, what causes this crisis, as we said, the overuse or the inappropriate prescription, extensive agricultural use, very few new drugs being available, and so on. And how can we manage this crisis? And new approaches to treating bacterial infections, and finally, hopefully, at the end of this session, we would be able to have some kind of a take-home message and a policy decision on what should be done to at least have us better prepared to face this crisis in the years to come. For this town hall meeting, I'm going to request Dr. Anand Kumar, CEO of Bugworks, to co-host this session with me and give his perspectives, as well as put together the questions that the panel can address. And I'm going to request all of you in the audience to please actively participate and bombard the panel with questions, and also any effective suggestions or queries or ideas that you could offer to this. Anand? Yeah, sure.
Thank you, Dr. Bipin, for this great opportunity. I think this is the third time I'm coming for this conference, second time co-hosting it. It's a great opportunity, honor to have internationally renowned people to work with, to talk to, and a fantastic audience to speak to. So are you excited about the panel? Yes. What is this? Are you excited? Yes. Come on, this is a very, very important topic. It's very in vogue. I hate to say it, it's in vogue because this is the topic of the season, if you will, but it impacts our country and many other countries in big ways. I just want to give you a quick background on myself. I'm neither a scientist nor a clinician, so I'm a complete imposter on the stage. But what I do know a little bit about is startup companies. Bugworks is my 5th company, and I work with I'm honored to work with great scientists and try to bring commercialization and economics and licensing and those important attributes to science. Look at the situation we are in. You heard Professor Victor's talk this morning. You heard Bipin also, Dr. Bipin opining about this. This is the perfect storm, the perfect crisis storm, therefore the perfect opportunity, right? There is no innovation. Big pharmaceutical companies don't innovate in this space. The beast is so difficult to tackle because of the mutations. Major abuse of antibiotics. In the United States, the abuse mainly happens by the animal industry that consumes 72% of the antibiotics. In our country, you don't need a prescription to get an antibiotic. You know, the rest is pretty bad. The regulatory environment to bring out antibiotics is still rather difficult, so nothing has changed there. Awareness in countries like India is still slowly coming up. That is why you find Times of India, The Hindu, Indian Express, everyone starting to write about superbugs, super drugs, because the awareness is so little, particularly in our rural areas. Diagnostics. How can you treat a patient without diagnosis? Right? And if you look at it, a huge gap in the entire antimicrobial resistance area is lack of new antibiotics, but also lack of diagnostics. So in our panel, we'll have some thoughts around new diagnostics, so that while you are coughing in front of your doctor, somebody should be able to say that you have a bacterial infection and be able to say that you have Pseudomonas that's resistant to this antibiotics. We are far away from that. So huge problem equals huge opportunity, right? Amrita University, just want to spend 2 more minutes, right? I've had a fantastic experience working with Amrita University. I've known Dr. Bipin and his colleagues ever since you started this program. Currently, you're rated one of the best in the country, and I'm really proud of this program. And you should give yourself a round of applause. How many universities have a 2-day program on antibiotic crisis? Just think about it. How many do, right? And the fact that your hospital in Cochin is rated the best in the country from a microbiology perspective, that also needs a round of applause, right? In a country where reporting is so difficult, in a country where microbiological data is so hard to come by, this hospital has actually published its results, and it's relatively better than its peers. So what is the format for the panel? We have fantastic experts. Each one will be asked 1 or 2 or 3 questions, themes, and I've requested them to keep their responses to between 3 to 4 minutes, and then open it up to the audience if somebody wants to have a quick opinion about that topic. We'd like to wrap up in 1 hour 10 minutes, or 15 minutes, and leave 15 to 20 minutes for questions. The best question that comes from students will get a prize. It's not going to be a 5-star chocolate, I promise you. But the best question that comes from you will have a paid internship in Bugworks next year. Okay? So you better participate actively. And why are we doing this panel? We're not doing this panel to take 2 hours away from day one. We have top people who have come from all over the world and all over the country. Why are we doing this panel? Dr. Bipin and I spoke about why do we need the panel. It's great fun, great ideas, thought processes, thought leaders are here. It's a complete waste if we don't capture the important key attributes that come out from these various topics. So I have 2 students, actually 3 of them, thanks to Sridevi ma'am, Akshaya and Natasha. I want to thank them, who are going to scribe this entire panel. And at the end of the panel, we are actually going to create a white paper in the coming days. And this white paper will be submitted to ICMR, to WHO, to Department of Biotechnology, Department of Science and Technology, and the Wellcome Trust. So this is really good stuff. We want to get the best out of these folks, capture it, so we do something meaningful with it, and not just walk away after 2 hours. Sounds like fun? All right, great, fantastic. And my first question goes to Professor Nizeb. First of all, thank you for a fantastic speech this morning. You stole my thunder completely, but that's okay. It was great. You had everything in there. You spoke about several out-of-the-box techniques, and at the heart of your talk was innate immune therapy. I'd like to hear about microbiome. India's looking at microbiome. I'd like to understand from you what is going on in the world of microbiome. I have another part of the question. I also understand that your lab has done some amazing work in phage therapy. So if you'd be kind enough to answer a 2-parted question. One is microbiome, and educate us with your erudite inputs, as well as what you've done in phage therapy. Professor.
Okay, those are good and important questions. I think the human microbiome I highlighted in my original talk to emphasize that it is really the first barrier of defense against serious, opportunistic, pathogenic infections. The normal microbiome coats all the surfaces on our body that a pathogen would need to invade in order to gain an initial foothold in the body. So each time we inappropriately prescribe antibiotics or inappropriately prescribe a broad spectrum antibiotic when a narrow spectrum would do, we deplete this first barrier of defense against infection. So recognition of the importance of the intact microbiome has to be a cornerstone of therapy. And then there's the concept that the microbiome itself could be enhanced to promote wellness, resistance to infection, or to be curative in mucosal infections with drug-resistant pathogens. Many of you are probably aware now that one of the leading infections that is a complication of broad-spectrum antibiotic therapy is Clostridium difficile colitis, a very severe infection with significant treatment failure and mortality rates. It's not an antibiotic-resistant pathogen, but it arises when the normal flora is depleted. And we used to treat this with antibiotics such as vancomycin or Flagyl orally, but ended up in a vicious cycle of frequent failures and reinfections. Recent research has shown that stool transplantation of normal flora from donors, and it doesn't have to be a relative, can be the now standard of care, beat all antibiotic treatments for this infection, and is now widely used in America. And many companies are looking to develop basically pill forms or suppository forms of ideal stool organism constituents for such treatment. And I think we'll look to see whether that can be expanded to good treatment outcomes in other GI tract infections, such as invasive Salmonella, Shigella infections, and that will be looked at. Also could be looked at for recurrent strep throat or recurrent urinary tract infections or vaginal infections, colonization with group B streptococcus with replacement. So I think that's a big idea. And this can also be achieved through prebiotics, giving nutritional therapies that promote the growth of healthy bacteria over pathogenic bacteria. Phage therapy, I would say that most of our research in phage in the lab has been focused on their use in agricultural settings, such as infections in fish farms. But I want to highlight an amazing clinical case of phage therapy, which I can share to you because the patient involved is a professor at our university, the wife a dean at our university, and they are writing a book and movie script about the experience, and the case report is now under review at the New England Journal of Medicine. This was a 60-year-old man with diabetes who was vacationing with his wife, both professors, in Luxor, Egypt. And while he was there, he developed severe pancreatitis. This is a disease where your pancreas is inflamed and the enzymes spill into your gut and do a lot of damage. He was critically ill and in an ICU there, medically airlifted to Germany, medically airlifted back to America. And along the way, probably in Egypt, acquired a Acinetobacter baumannii infection that became pan-resistant, resistant to all carbapenems, resistant to colistin. There were no treatment options, and he was failing clinically. He had 6 or 7 episodes of frank septic shock, and really the discussion was circling around no options, no hope for cure. In our laboratory, we were doing experimental things along the lines that we discussed with azithromycin, rifampin, other things that led to some temporization but never cure of the multiple abscesses in his abdomen. And then, really through the inspiration of his wife to do everything, we decided to try to do phage therapy. Bacteriophage are viruses that can infect bacteria and are lytic. They're used in a few places in the world, mainly Soviet Georgia. We contacted the experts in Soviet Georgia. Through the Belgian military, we received a number of potential phage. Unfortunately, none of them worked. But then working with the US Navy, biotechnology companies, and a couple academic labs, ultimately cultivated some strains of phage that were lytic for his strain and started to administer them twice a day, intravenously and directly into the abscesses. And he improved. And it was not a completely smooth course. The organisms became resistant and we had to select new phage over and over again. But over the course of 6 weeks, he was weaned off all his support. And after an 8-month hospitalization, celebrated his discharge from the hospital with a nice party at his home. And you're going to hear about this story. It's not 100% clear. We had to achieve single-use approval of the FDA administration for compassionate use of the phage, and we are inspired now to try to create, maybe in collaboration with the US Navy, which has a presence in our city of San Diego, a clinical phage therapy center.
Thank you, Dr. Victor. That is excellent. Great idea for startup companies. Pill forms of stool, not a bad thing. Prebiotics. And of course, we'll be very interested in seeing their paper on phages. I think it sounds fascinating. Any quick comment from anyone here? Like to add on to it before we move on? Okay. The next question is for Dr. Nayar. He's a doyen of this industry. He's worked in the pharma industry for decades and has also been advising the government on many important topics, including AMR. Dr. Nayar, as I understand it, TB is a crisis situation for India. 2 million deaths per year, 2.5 million new infections per year. It's a crisis. We are seeing MDR TB, we're seeing XDR TB also here. I'd like to understand from you the program that was run for TB and where we are with respect to TB. If you were addressing an audience that also included people from ICMR, DBT, etc., I'd like to get, some crown jewels from you in terms of what should the government be doing in promoting TB treatments, because it's really a huge, huge problem for our country, morbidity and mortality, and it's our problem to solve. So over to you, sir.
Thank you very much for this opportunity. This morning when I walked in here, two things occurred to me. Number one, I seem to be the only one representing an R&D based multinational corporation, which has been the second largest company when I joined them, that was Ciba Geigy, and today as Novartis continues to be the second largest company. Now my own experience is a case study. In fact, one can write a chapter or even a book on what has happened in this particular line. If you look at the TB scene worldwide, there are 10 million TB cases. Prevalence of TB is 10 million people. That prevalence means those who are infected with the disease, who are symptomatic, who require treatment or under treatment. Out of this, 2.8 million are in India. That means almost 32% of the world's morbidity and mortality are in 16% of the world's population. We are 1/6 of the world's population. So it's a major, major problem as far as India is concerned. And practically every 2 minutes, one person is dying out of TB in this country. Not of resistant TB, but TB in general. Now, out of the 2 million people we are talking about who are affected in India, 2.8 million, almost 10 to 15% are with multi-drug resistant TB, or what you call extensively drug-resistant TB, MDR or XDR. I started my career in Ciba Geigy in Basel, Switzerland. At that time, we had a project on the development of rifampicin. Rifampicin is a drug which was discovered by a company called Lepeti in Italy, which was subsequently taken up by Dow. It became Dow Lepeti. They licensed this rifamycin. Rifamycin is a basic molecule to Ciba Geigy at that time. And we as chemists were supposed to make derivatives of rifamycin, where we made 3-formyl rifa-SV and also what we call rifampicin today, which is converted with N-aminopiperacin. So that's a rifampicin. For the last 50 years, the standard line of treatment of TB is a 4-drug regimen: rifampicin, INH, pyrazinamide, and ethambutol. That's the standard treatment now. Now, during the last 10 years, out of the 50 years, we have seen extensive resistance, first to INH and pyrazinamide, and today extensive resistance to all 4 TB drug treatments. It's a major, major catastrophe. In 1972, Ciba had a setup called Ciba Geigy Research Center in Bombay. One of the mandates that was given to the Indian Center was to set up a TB research unit. And we were the first ones to set up an in vivo testing facility where we developed a rodent model for active clinical pathological TB bug. That means Mycobacterium tuberculosis. The benchmark and the standard of treatment was to consider the survival time extension. If you give to a rodent an S37RV strain or a clinical pathological strain, on the 20th day, the rodent will die out of infection. So if you give an experimental drug against a control, we study the survival time beyond this 21 days, and that shows that the drug is effective. Based on this model, our research team, which has been at that time the largest research team in nitroimidazoles, the first letter on nitroimidazole was metronidazole. That is for amoebic hepatic amoebiasis. We tried it on TB, and we had a molecule which was a 5-nitroimidazole oxazole. that was active against multi-drug resistant TB. Now, we took it up with the parent company who is responsible for commercializing a molecule, and they came with the excuse that already nitroimidazoles are considered mutagenic. And if they are mutagenic, possibly they become carcinogenic. Therefore, they said when this drug becomes a drug, if at all, 5 years down the line, we don't want to develop a mutagenic drug. But the real reason was different. If you look at the total world TB market, the 4 drugs that I mentioned, rifampicin, INH, pyrazinamide, and ethambutol, together has a market value of $700 million. As against this, in 2012, when atorvastatins, one brand of Pfizer called Lipitor had a market of $14 billion. In other words, the entire global market for TB was 5% of the market for a single brand of atorvastatin. Why would a pharmaceutical company invest for this such a small market when they have the opportunity to develop drugs for chronic diseases like cardiovascular diseases, CNS diseases, musculoskeletal diseases, cancer? That's why all the companies stopped research in antibiotics. The last antibiotic discovered, the class of antibiotics discovered was in 1962, which was rifampicin. Subsequently, no new structural class has been discovered. Therefore, the question is that our parent company decided not to pursue with a multi-drug resistant active 5-nitroimidazole oxazole, saying it is mutagenic, we don't want to pursue it. The real reason was commercial. And that continues. With that kind of scenario, the United Nations formed a committee called Global Alliance on TB Drug Development. And they identified a molecule which is PA824. In 2013, when Samir Brahmachari was the CSIR Director General, he signed an MOU with the United Nations to license his PA824 to India, to CSIR. And CSIR then took up this license and appointed a committee with Bal Ganesh as a coordinator, myself, Dr. Soumya Swaminathan, who is now the Director General of SCMR, and Dr. Jawahar, to look at clinical trials of this PA824. With the change of guard at the CSIR, Samir Brahmachari leaving, and the OSDD program coming to practically a halt, the current Director General of CSIR has very little interest in pursuing OSDD. That is the fate of PA824. I would stop here, and whenever you have questions, please come back.
So, some very key points, right? So that you all know, drug discovery is a very complex area. It can take 7 to 10 years to bring a new drug, and anywhere between $500 million to $1 billion. So if your peak sales is not at least $1 billion to $2 billion, you can't get into drug discovery. In TB, total market, he said, was 700 million worldwide. It sounds like big numbers to us, but you have to look at it in context. In infection, a new drug, think about it. You want a new drug to come out, but you don't want it to be available to everyone. You want to use it carefully through stewardship, so that as a last resort drug. So you don't have volumes to justify new drug. So we need new thought process around the economics, and I'll come back to that later. Over to my friend Dr. Jeff Perry. I must say, Jeff must have been a Malayali in his last Janma. I see him so comfortably walking around Amrita University, even his chappals are very Mallu. Just put one mundu for him and you can talk to him in Malayalam. That's Jeff. All right, Jeff. Jeff is doing some outstanding work in structural biology. It's very, very key in understanding structures, and which becomes a key building block in the entire drug discovery process. Jeff, I'd like you to elucidate on what are some of the new techniques going around in structural biology, particularly to study things like virulence factor that Dr. Victor alluded to this morning. And please bring us up to speed on the world of structural biology as it relates to anti-infection.
I'll start off with saying Engeniunda. That's about my limit. I'll have to learn some more. This is California Kerala Cash. I think that's what we're doing here. Good question. So what's happening with modern structural biology? So it's very important in early stage drug discovery, and there's been a fair amount of resources thrown in by the NIH, National Institute of Health, in an area called structural genomics, trying to uncover protein structures. And what's happened was, before structural genomics, we had about 10,000 crystal structures, and now we have about 100,000 crystal structures in the protein data bank. So that's good. That's a fair resource that we can mine and use computational methods and so on to try and do drug discovery. But we need to do a lot more. And so my training is as a molecular biologist and as a biochemist, and I'm playing in the area of biophysicists, which is fun, and I have much to learn. But we need to bring the biophysicists towards the cell biologists, because we don't want to be just solving random sort of crystal structures. And there's a biological reason behind this. If I look into the protein data bank with its 100,000 crystal structures, most of those structures are just of individual proteins. But that's not the biology. What we can tell are that most proteins are in assemblies. They're in large assemblies. Certainly, we see it in archaebacteria, that most of the proteins are actually in a complex and an assembly. And also just in terms of how biological signals are sent through the cell, maybe from the outside, all the way down to your transcription factor and DNA, it's very much transient interactions that sort of are causing these conformational changes that are allowing the signal to get through. And so I think that's the area that structural biology needs to get into. It needs to get into these conformations, these assemblies, these dynamics. I think that's where you're going to be able to generate new drugs. And so it's a new space that we haven't really looked at in terms of drug discovery. And I think that's just beginning to come about. There's the few techniques that are coming through. There's the free electron X-ray laser at SSRLs. So it's really exciting. It's the power of this beamline at SSRL. It's like 10 to the power of 9 more powerful than a typical synchrotron source, which is incredibly powerful in itself. And what that means is that you can shoot crystals in a femtomolar time frame. And so now you can get structures in a blink of an eye, and now you can actually start seeing the dynamics of the protein. You can actually start seeing experimentally dynamics, how proteins are moving and breathing and so on. And I think that opens us up to a new area of drug discovery. And we've been doing that already, doing a technique called molecular dynamics, but that's in silico and that's theory. But now we can start trying to bring in experimental techniques and understand not just the crystal structure of this virulence factor, but maybe all the way it moves in solution, and maybe that trap it in a conformation that's inactive or something. So that's one area of structural biology, getting to the dynamics. And then the other areas, things like cryo-electron microscopy, they're incredibly exciting. We're beginning to get through this technique. Electron microscopy is normally a low resolution technique, but now it's getting into sort of the crystallographic area, so we can start looking at very big assemblies. And that's really where I think the biology is, and maybe the new drug discovery will come from, not just from targeting individual proteins, perhaps these complexes and how they're coming together. Maybe we can target the protein-protein interactions or trap assemblies, make a receptor inactive and so on. And I think using things like cryo-EM, I think will allow us to look at these very big architectures and start controlling them. And there's a few other techniques, things like small angle X-ray scattering, and I think that's a nice technique that's going to start coupling with NMR. So NMR is a good technique for dynamics, but it has a lot of limitations in terms of the models that are produced. But if you start adding the techniques together, if you start creating hybrid techniques, if you put NMR with X-ray scattering, with crystallography, you maybe throw in some FRET results and so on, I think you're going to start really understanding the assemblies within inside a bacteria, or the assemblies within inside a cell. And I think that is sort of where we're starting to get to, and I think that's where we really need to go to for developing maybe new therapies. And I mean, obviously there's very exciting, doing drug repurposing. I think that's the way to go right now, but we're going to run through those drugs, and then so we need to start developing new things. And I think, we've done as much as we can with individual proteins, and now we should start going for those biological complexes.
Great, thank you very much. For those of you interested in structural biology, there's a lot to be done in looking at dynamics of protein interactions, and these new techniques that you alluded to. Dr. Bipin, question for you. As a country, I understand that we have great strength in structural biology, right? I work with Ramsamy and NCBS and other institutes. Are we looking at this space from an Amrita University perspective in developing structural biology and bringing certain facets of that into the antimicrobial work you're planning to do? Would you have any comments on the structural biology area?
As such, we haven't done too much in that area as yet, but more from a perspective of what we have focused on in the area of natural products chemistry, looking at, as our Dr. Ashok Banerjee likes to call it, phytomedicine, phytochemistry, converting it into phytomedicine, looking at individual structures, because, for example, Ayurveda is popular. Kerala is the home of Ayurveda. But if you look at, or if you talk to a Ayurvedic physician, he gives you a concoction that is a mixture of several different extracts. And it is a age-old remedy for any disease state. But if you ask what is the active component in there, that's not known. And that is the approach that we are taking in at Amrita, where looking at well-known natural remedies, but trying to identify what is the active component in there, establish the structure, establish the structure-function relationships, if any, and thereby provide greater credibility for these established remedies. In doing so, also being able to identify how some of these natural remedies could be added in conjunction with established therapies, and see if allopathic plus Ayurvedic remedies could be more effective in their use.
So this is very interesting. I see the possibility of a collaboration with Jeff, if not already there.
We're doing that already. And
Right,
so also with Victor.
So with Victor. Perfect. Very, very nice. Thank you for that.
Just comment on the current status on systems biology or structural biology in India. There are about half a dozen laboratories engaged in systems biology and structural biology. But unfortunately, all these labs are working on chronic diseases. Diabetes is a #1 priority for systems biology people in this country. And most of them are using to develop biomarkers and diagnostic reagents rather than for curative approaches for drug discovery. Biomarkers are really the targets of most of the systems biology companies. It has two applications. One is for developing diagnostics, another is for standardization of natural extracts. And if natural extracts in Ayurveda is going to be a target area, systems biology has a lot of role, and perhaps they should take up that.
And it's also something for Renu Swarup, Dr. Renu Swarup in BIRAC. They're looking for areas to invest in that are specifically addressing AMR. So it's a great input. Thank you for that. Thank you for that. Dr. Anirban, great talk this morning, firstly. I'd like to get your views on the area of diagnostics. As I said in the preamble, diagnostics is a huge void, right? Typically when you go in, the doctor really doesn't know whether you have a viral or bacteria. If you have bacteria, they don't know which the species is. And even if they ever come to know the species, it's very hard for them to know what you're which drug you're resistant to and which you are sensitive to. It takes 3 to 4 days, sometimes 5 to 7 days in India, because we're using age-old microbiological techniques. Maybe it came from the 1940s, like some of the other techniques that Dr. Victor alluded to in the broth, right? These techniques come from the 40s and 50s. So I'd like to understand from you, Dr. Anirban, what is the state of the art in diagnostics? Where do we need to be? And is there some recommendation from an ecosystem or public policy perspective that you'd like to share with us?
Well, first of all, thank you for having me over here. Diagnostics is a big booming market in India because of its necessity, particularly in the rural parts of India where the sophisticated instrumentation and all that is not available. But also per se in the bigger cities, the traditional way of diagnostics or the way the diseases are being diagnosed is changing, but we need a lot more overhaul in those techniques. And it partly comes from the fact that either we are ignorant or we tend to be ignorant. We just do not wish to acknowledge the problems that we have in hand. So I'll point out a couple of things over here. So Professor Nizay is here and he would say that in the West, it is mandatory that, that women who are pregnant, so they would undergo at 37th week of gestation, they would undergo some diagnostics for the presence of group B strep, which is mandatory out there. And if at all you are found positive, so as to stop the transmission from the mother to the newborn, they would be provided intravenous antibiotics. And generally it is penicillin group, clindamycin and all that. And you would be given intravenous antibiotics over here. So my first kid was born over there in San Diego. I was there in San Diego for like 3-4 odd years or so. And then when I came back to India, the second one was born in Hyderabad. And when the day of the delivery, I asked doctor, would you not, did you check for the GBS presence or not? And the answer is like, no, we do not. So the question automatically comes like, why not? Like, it's not there. That's the automatic answer that comes from out. And the question that I asked, the question that follows up, of course, well, are we sure? So I said, no, we just know that it's not there. Great, fantastic. So either we know for sure that it is not there, or we are just ignorant that, or we just do not want to acknowledge the fact that it is there, but we just do not care. Now, after acquiring a position in IIT Bombay, we started working on this particular thing, and we recently published a paper last year where we actually been able to show that, and I'm talked about in Amrita 2015 during my visit regarding that only, that if at all a woman has colonized GBS in the lower genital tract, so you do not have an invasive infection, you just have a non-asymptomatic colonization. There are no symptoms, it's asymptomatic. But you are still prone to preterm birth related outcomes because of that particular colonization. And I looked at the literature. The worldwide abundance of this particular bacteria, group B streptococcus, is 20 to 30% worldwide in the pregnant woman. And in India, the last bit of study that has been done in 1999, and at that point of time, the prevalence rate was somewhere around 16%, which is not much less compared to the worldwide standards. But even after so, we completely disacknowledge this particular possibility that this bacteria can be present and is actually one of them, can be one of the major reasons for the preterm birth or neonatal sepsis or neonatal deaths, which is one of the highest proportion of India has the highest dubious distinction of having the highest number of neonatal deaths in the world. So we are just not acknowledging the fact that it is there, or we are just not ignorant. Now coming to the point is that development of diagnostics and all that is like we are actively looking into having some portable instruments which does not necessarily require a lot of instrumentation capability, a lot of technical capabilities from a person in order to maintain or actually manage those instruments. Because in the rural areas, if at all you go, it's pretty much like either you see or you do not see it. So it's more of a visual thing. So can we actually take something which is very, very portable, take something very, very miniaturized, very, very small, and something which is not technically very, very complicated to the interior parts of the India and actually be able to tackle the problem? Two things, and we are targeting particularly two things, is that in the neonatal sepsis cases where the patient is actually having very, very less time, because the traditional antibiotics and all that, which bacteria or virus is causing causing the disease, if at all you want to know that, it just takes another 4 or 5 days. And by the time you actually determine 4 or 5 days, the patient is already gone. So we need some point of care diagnostic systems that are cheap, miniaturized, and that can be taken care by normal average individual and not very highly technically skilled people. So we are trying to tackle that, and also if at all we can, simultaneously we can have that information that what are the kind of antibiotic resistance. Let's say a child comes to the hospital, a neonatal kid, probably 2-3 months old, he or she is suffering from neonatal sepsis and having high fever or very low body temperature and all that. You're administering antibiotics, it's not working, the symptoms are not improving. So what kind of things is it antibiotic resistant? What kind of strains are being present over there? So we are trying to develop that kind of techniques, and possibly in the next few years time, if at all hopefully can develop all that, then that can be in the market.
Excellent. Very, very good input. Again, an opportunity for us, right? If somebody creates a company or a group of people come together, gets funded by DBT to come up with a kit for GBS. I mean, this is news to me. I learned something from what Dr. Anirban said, that such a large percentage of preterm birth happens because of lack of diagnosis. I mean, that's pretty shocking. Dr. Bipin, I think that's a potential input that we should take to Ministry of Health to see if something's been done about it. And also a good grant challenge for Wellcome Trust and Bill and Melinda Gates Foundation, who are constantly looking for such ideas. So I thank you for that. Before we go to the next round of questions from this esteemed panelists, I'm going to open it up for questions. I think the online people are faster than the offline people. So we have some online questions that we're going to put up here. Am I right? Am I right? Could we use this time to show some online questions? And if it's not directed to a particular panelist, I will, Dr. Bipin or I will direct it so could we use that?
In the meantime,
Yes.
we have some experts from within the Amrita system, like Dr. Anil Kumar or Dr. Raja Biswas, to comment on any of these points.
Great point. Let's get some inputs.
Thank you, Dr. Bipin. Thanks, everyone, for inviting to this meeting. Superbugs, super drugs. Okay, let me introduce myself. They've blamed me throughout the day for using outdated techniques, giving wrong diagnosis, giving wrong reports. I'm a clinical microbiologist. I'm the one who uses that plate to do the test. I earn my living from doing that. So, to be frank, the lecture was excellent and even it was an eye-opener for me also. Technically, it is very difficult, not cost-effective in our setup to do a test that Sir was recommending. It's beautiful to say to get a point-of-care test, you put a drop of sample and you get a diagnosis. Very little happens in that field. But if you get something, GBS kits are already available, nobody uses it because of ignorance and cost associated with it. We have to import it. If you make an in-house kit, an Indian kit, it would cost less and it would actually be worthy enough to prevent premature births. It has got long-term implications. Super bugs. Now that's a bad name. Somebody mentioned about New Delhi metallo-beta-lactamase, NDM1. I almost lost my job for that. The first report that named NDM1, I was one of the co-authors in Lancet ID. I had a tough time defending it. Then we stopped working on it. It was a fiasco. The media blamed it, negative publicity. A lot of negative publicity for Indian researchers who collaborated with the UK counterpart. From that day onwards, nobody collaborated with anyone outside. ICMR blocked everything. Everybody was terrified. Even I stopped working on it. I had to keep my job, isn't it? So, multi-drug resistance, superbugs, everything is in India. After NDM1, nobody worked on it, so we don't find any more superbugs coming from India because we are not working on it. We don't have the capacity to work on it because those are high-end molecular diagnostics that we don't have access to, we don't have money to spend on it. But still we have few things. If somebody can Google Candida auris, that's a new superbug, a Candida, which is a yeast fungus. So it's continuing. The bacteria has finished becoming superbug. The fungus is coming up the next. And we do everything under the sun in India now. All sorts of transplants. All sorts of malignancy patients are treated with high-end care, high-end antibiotics, monoclonal drugs. So we have all superbugs here. It's very difficult, as Sir said, you find pan-drug resistant. I'm surprised that I have to give a report where none of the antibiotics is sensitive. What will the physician say? There's something called as kneel down and pray. That's the only thing that you can do in such cases. But Sir already told me that I am reporting it resistant may not be actually the fact that it is resistant. Each individual behaves in a different manner. The body works in a different manner. So if you even give a resistant drug, the patient may respond. So there's something called as God sitting in the hospital taking care of the patient. And the patient actually recover. Most of them don't die actually of these superbugs. Though it's rampant, people don't die that fast because of the patient's response to the drug. It may be different and he may get rid of the infection. So it's really interesting to work on this particular aspect, to stop this menace from going further, to do research on it, to find new kits for diagnosis. Half the problem is diagnostic, as he said. We just hit it, the black, what do you say, in the dark. We don't know what the diagnosis is, we pump in antibiotics. How many of you have taken antibiotics in the last 10 days? You could have taken, yeah. You don't know what's happening. All you need is salt water and gargle. But nobody believes in that particular aspect if somebody tells it. Even, you see, the patients are very educated. If you don't give them an injection, they don't believe that you are treated. See, it should be painful. If the capsule is black in color, it's more effective, they think, rather than the smaller white capsule. If you give him for 5 days antibiotic, they think it is more effective. And after giving antibiotic, he may say that, please do a chest x-ray also, see something wrong. So it's the patient's mentality that's also driving antibiotic resistance. Think of the little kid, my daughter having cough. 3 days cough, the parent can't stand even 1 day of cough. They immediately go to the pediatrician. Pediatrician has to have a flow of patients. He can't say go and gargle. It creates a wrong impression the doctor doesn't know anything. My child is suffering and he asked me to gargle. So it's the patient's perspective, the doctor's practice, and over-the-counter availability of drugs. You go anywhere, take any antibiotic, nobody will question you. Now the last resort is colistin. Now colistin is maximum. Everybody has had colistin. How many of you are non-vegetarians? Just raise your hands. Okay. Okay. Colistin is a drug you must have heard here. That's the last resort, very toxic. 3,000 rupees per vial. If you give 9 millions per day, it will be something 12,000, 13,000 rupees per day. It is mostly used in poultry industry. The chickens drink it in their water. They feed in the water of the chicken. So that they don't get infected, they become fat, so that you can have good chicken. So the most amount of colistin is in your chicken. So everybody has had colistin. That's the reason you have such rampant resistance everywhere in India.
Thank you very much for those inputs. But hopefully it's not all gloom and doom. Some companies like ours have drugs that are working on pan-resistant, but it'll take a few years to come out, and hopefully it won't be toxic. Lots of inputs he gave, right, about the abuse, misuse of antibiotics, the socio-economic strata we come in, the behavior patterns we have here. All that falls into an important area called stewardship. And the question that came from Janani Krishna Kumar was on stewardship. So it is a perfect segue that you mentioned about stewardship. Responsible use and careful use of antibiotics is the simplest meaning for stewardship. Right? So in Bangalore, my team that works on antibiotics, 7 of us did a survey. We went to 7 different pharmaceutical pharma shops, and we just stood there and coughed. So I said, antibiotic, madam. You know, it's so easy to get an antibiotic. And obviously, we were just acting the cough, but it could have been purely viral. So I'm going to ask the panel to talk about stewardship. Very, very important area. Thankfully, just 3 days ago, India woke up, finally. Ministry of Health, CDSCO has come out with very strict red line guidelines that say it's going to become as difficult as getting an opiate to get an antibiotic. I think we should give a huge round of applause for that. It should be that difficult, right? Because we abuse it so much. So it's going to become very difficult. Now implementation, like demonetization, etc., it's always complex. But at least that MOH has taken this thing. The microbiologists, I'm sure, will be very happy because it will take a while to implement. But if we are even 50% successful in that, it will reduce the rampant use of it. And avoid Kentucky Fried Chicken unless you want colistin, based on what you said. So I'm going to have Dr. Victor talk about how are you all handling stewardship in the US? And again, it's a two-parted question. One is, what do hospitals do? And what do you, infection diseases specialists, ID specialists, discuss with each other in doing what you can do from a prescription protocol perspective to help stewardship? Love to know your thoughts.
Well, I absolutely agree with the sentiment of the question that antibiotic stewardship is a true cornerstone of what we need to do moving forward for the crisis. In our country, we do not have national guidelines for stewardship, nor even at the state level. we do have some guidelines that come out at the state level that are increasingly sophisticated and rational from a public health perspective to do reporting of multi-drug resistant cases that is done in an anonymous fashion initially to the public health authority to help encourage hospitals not to hide their cases of antibiotic-resistant infections. But if there is a cluster of cases that rises to the level of being a public health concern that can implicate that public changes in public health behavior or exposure are important, these will be reported and hospitals will be identified. Stewardship, most large health practices and hospitals have developed a stewardship individual or team to take leadership in this role. The amount of support and time dedicated to this varies tremendously, from 10% of one individual's time to a full-time antibiotic stewardship czar. But the goal is often, driven in terms of economy and patient outcome on a hospital-by-hospital basis, and trying to come up with a formulary of antibiotics that is not redundant, that is associated with good negotiated prices from the providers, and is related to efficiency, not necessarily to restrict usage to minimize the development of antibiotic resistance. But they do move in the same direction, and we hope there could be some benefits. The success of antibiotic stewardship needs to be coupled with infection control practices that monitor outbreaks, as well as hygienic interventions. Hand washing, for example, is one of the most effective ways to ensure that as the doctor moves or other healthcare worker moves from room to room, they don't serve as an inadvertent vector for infectious fomites that can spread resistance. We also cohort patients or isolate patients with the highest risk infections and practice universal precautions which are designed to assume that every patient could be the source of an antibiotic-resistant infection. So these things are coupled. They're done extraordinarily well at the best hospitals and begrudgingly at other hospitals. But it's an area that I think is a good target for national task forces and the sharing of information, successes. It would be great if academic journals developed publication streams and special issues and a true academic subspecialty of stewardship as a key aspect of our success in this crisis.
Thank you, sir. National Task Force, that's a good suggestion to the folks at ICMR. And also that prevention is better than cure. Just using soap water or alcohol rub, as they say, makes a huge difference. I just read a report from WHO that says that in certain European hospitals, under controlled environments, when they force everyone to use alcohol rubs ever so often, there's a particular protocol, that there was a 40% reduction in healthcare worker-related spread of this. So I think prevention is better than cure. I'm going to keep to the same question because it's very important, because that leads me to a next question for Dr. Nair, which is a rather uncomfortable question for you, sir. Coming from the pharmaceutical industry. In India, stewardship or lack of stewardship is not just us abusing antibiotics. You know, chicken 65 manufacturers doing abuse of antibiotics, but pharmaceutical industries, particularly the large antibiotic manufacturers in certain states, it is well known that the way they take care of the effluents that come out of the pharma industries, you know, if that is laden with antibiotics that is going into the soil, it's going to make its way into the animal chain and therefore make its way into the human chain. Sir, is what I'm saying true? A, 1 minute, sir. And two, if so, are we doing anything as a country to stymie this particular cause of spread of resistance? To you, sir.
I will not try to defend the indefensible, which is a pharmaceutical industry. Now, if you, sometime back, New England Journal of Medicine published a paper saying that 5% of all hospital admissions in the infection area has been due to nosocomial infections or hospital-generated infections. 5% of the admissions. That's is due to many reasons. In fact, the ICU is the biggest reservoir of resistant strains at the moment because it's contained. Now, some years back when Dr. Harshavardhan was a minister of the Delhi government, he promoted a committee called the Society for the Promotion of Rational Use of Drugs. Society for the Promotion of Rational Use of Drugs. I was a member of that committee, and we made recommendations, and some of the doctors at All India Institute of Medical Sciences were roped in to develop standard treatment guidelines for every therapeutic indication. Naturally, the government could not insist on doing it because they had control only on the government-run hospitals. But Dr. Harshavardhan saw to it that all government-run hospitals follow the standard treatment guidelines, which shows equanimity in the prescription of antibiotic drugs. The clinicians revolted. They said, who are you to tell us what to prescribe, what not to prescribe? So statutorily, it was very difficult for the government to have a statute brought in to say that for a particular disease, this is a standard treatment guidelines. Exceptional cases are different. So it's an extremely tricky thing because ultimately the arbiter of prescription is a medical professional. As far as the industry is concerned, industry has only one motive, particularly the major motive of increasing shareholder value. As long as it's an industry, this is going to continue. They will try to maximize profits for the benefit of the shareholders. So whether it is animal health, human disease, animal disease, this situation is going to continue. That's the present situation. We need to make recommendations like the Society for the Promotion of Rational Use of Drugs, done by the doctors for the doctors, those who are peer groups in particular area.
Dr. Bipin, clearly someone from AIMS or Ministry of Health. Next time we have such a panel, we'll add them on in, but the two of us should try to rope them in and share this because it's such a serious situation. Now, I'd like to, sorry, you have an opinion?
Easy to blame industries, but what about our own guts? Every day we are releasing, suppose you are having an antibiotic, hardly 10%, 20% we are absorbing probably, going to the target. What about the 90%? How do you deal with that?
Non-compliance is a major issue with antibiotic resistance.
No, even if you suppose compliant, you are compliant, you are fine.
All drugs, including
Prescribed
steroids and fourth generation antibiotics, including moxifloxacin, including mefloquine, which are restricted items, are available across the border in any retail store whatsoever. You can order on the phone.
No. That is one part of the problem. I'm going a little away from this core problem, which is well discussed and well in. There's another problem is that when you are taking most of the things out of hospital, not everybody is in the hospital. We are in the houses, and every day whenever we're taking antibiotics, 90% is going to the sewage, and sewage is going to the water bodies. So industry is part to play their role, but what about this menace?
There was a Hindu article, India is drowning in its own shit. Forgive me for that word, but it was like that. Because of poor sanitation. You have billions of E. coli and Klebsiella that are the very superbugs in your own gut. I did a study for gut pathogens, E. coli, in a tribal population, some 4,000 feet above sea level, which doesn't have access to any road. So we went there, collected stool samples from the tribal population who never had antibiotics. And we checked for drug-resistant bugs. 20% of them had drug-resistant E. coli, that is a ESBL in their gut, without having been exposed to the antibiotics in the first place. So it is there in the environment. You go to Sabrimala and take the Pampa water, plenty of superbugs will be seen. You take any water source. NDM1 was seen in drinking water source in Delhi. So it is there everywhere. Indian stool has got plenty of superbugs. Our environment is full of superbugs. If you don't believe it, that's fine. But I tell you, 80% of my clinical isolates that I see are extended spectrum beta-lactamase producers. That is, the third generation cephalosporins is useless. So it's a scary situation that you don't realize, but that's because of the free availability and the free eating of drugs and the chickens that move around. So it's very difficult to control that unless and until government stops the prescription.
I hope the worst is over though, with the picture you're saying, and that we can move forward with stewardship, with new diagnostics. That's the whole idea, right? I think we have hit the worst. And now the government is woken up because one death got announced from the United States, and it was linked back to her picking it up from Delhi, and the whole thing broke out. But you're so right. Yes, ma'am, you had a question.
Hello. Yeah. I was wondering whether a global database, I don't know whether it exists or no, wherein all the multi-drug resistant bacteria which are there, how people are dealing, how physicians are dealing, the different clinical cases. If we have a repository for that, would it help the physicians and the biologists to come together and solve this global threat?
Can I take that question? Because I try to work on this space before we move on to the additional questions. The key issue here, it'll be lovely to have such a database. ICMR tried and failed miserably because most of the hospitals were unwilling to report. And I don't blame the poor clinical microbiologist. He or she is somewhere in the food chain. And no hospital wants to say, multi-drug resistant Acinetobacter, multi-drug resistant Pseudomonas. Nobody's going to come out and say it. Particularly here. What happens when patients stay, they get sick, they stay for 7 days, 10 days, like doctor said, right? It's fantastic for the hospital. So they completely, there's no incentive to go out and report, and nobody wants to. It's really hard. We try to collect this data from hospitals, even the top big name hospitals, very reluctant to give it. And the microbiologist is like, very, very scared when you go to talk about these things. So it's a little difficult, but such databases, there is a plan to build an app so that physicians can start reporting localized resistance parameters. In Vallikavu, E. coli, deep UTI. It'll be nice to know, no? It's not responding to cephalosporin, or whatever. It'll be so nice and so lovely. In today's day and age, we're building an app for everything, right? Becoming a cashless society. Why can't we have an app that connects doctors so that they can load their case history, so you know that, in middle part of Kerala, there seems to be a huge problem with meropenem. It'd be nice to know that information. Today it's just shooting in the dark. There is a plan to build such an app, but the difficulty is collecting that data from hospitals. But individual clinicians are actually quite happy that something like this is coming along. I'd like to think about it positively, that it's not that it's an end game, that we're trying to do something about it. Does anyone in the panel want to add something? Yes, please.
Just to respond to Sanjay's question, I think Bhavatosh may have some insight into the gut microbiome and how that would have implications on that.
So recently just I attended one conference in France. So we are discussing around the resistant genes in the gut of healthy Indians. So one Canadian guy, he presented that one healthy individuals, they might contain 5,000 resistant genes in the gut of India. Just imagine, you don't need to go to the environment. So even the pathogens, enteric pathogens, those are coming as superbugs. It's not like that they're getting that resistant genes from the environment. The pathogen, when you are eating, they are susceptible, and most of the pathogens, these are naturally competent. So once they go inside the gut, they're ready to uptake that DNA. They get that resistant genes from your gut itself, and then they are getting resistance. It does not matter what antibiotic you are going to use, because antibiotic have two conflicting behavior. One cases they help you to cure the infection, but the most dangerous side effect of the antibiotic, it helps the spread of resistant bugs. Unless until you not restrict the use of antibiotic, whatever you are going to do, it's not possible to stop the resistant bugs. That I can tell you.
Thank you for that. I'd like to open it up for questions from students.
So I have one question for Dr. Najik. So
Okay.
this is regarding the fecal transplantations. Okay, it's a really great discovery of fecal microbiome transplantations. But there are also several risk factors that also involve when you are transplanting some fecal sample from one people to others. So how could you identify the ideal donor for fecal transplantation, and how could you rule out the risk factor that associated with the fecal transplantations?
No, that is an extraordinarily complex area that sort of moves beyond current regulatory science. I mean, there's probably blood product transplantation is a precursor in which some information on donors is available. For example, directed donation from family members with proper screening is no safer than the general donor pool for blood product transplantation. So we would hope that a similar achievement could be foreseen for stool transplantation. I would say, though, there's very interesting research in many microbiomes, not just the gut microbiome, that there is not a single microbiome that is, universally beneficial for all individuals. So probably for everybody's immunogenetic makeup, as well as their diet and other health factors, that is most beneficial for you. And it would be interesting to think that maybe all of us, I'm being maybe a little bit silly here, but at the same time, I think there's merit to it that, when you're having that fantastic week in your life where you just seem very witty, maybe you had the best performance in your sport or music that you do as a hobby, things are going really well in your personal relationships and academic exploits, maybe you should bank some of your stool at that point to be used at a future time when everything seems to be going wrong. Because there are probably things that have been, cultivated, you've co-evolved to a nice homeostatic set point with your own flora. And it's unclear that any donor flora or even optimized flora would have the perfect result for you. Could probably repopulate with strains that are generally considered beneficial, but it's not individualized therapy. It's not a 6 out of 6 match bone marrow transplant. And I think we may need to consider that type of therapy. Or even if you envision somebody requires broad spectrum antibiotic therapy for whatever indication, that you should collect a stool sample to allow what we call repopulation of the flora, after we believe the antibiotics are out of the body and it's been treated. I think that it's really not unreasonable to think of it in that method, maybe, autologous.
So another good idea for a startup, repoop.com. Big freezers, exactly. Any questions from students? Oh, yes, please, ma'am. Please state your name and the question, please.
Good afternoon, I'm Akshaya Balasubramanian. I'm a third year undergrad here at ASBT. I actually just wanted to extend on something that Professor Nise said about maybe looking at personalized medicine, for even when you're looking at antibiotic resistant strains, or even prevention methods like, I mean, vaccination strategies and things like that. Should we look at it more from a personalized perspective as opposed to a standard that has kind of been meted out?
It's a question, right?
Yeah.
Okay.
So the opinion in general.
And you would like to opine on it, or no? Personalized.
Well, personalized medicine is the in thing now. Ever since the biologicals have almost 40% of last year's FDA approvals have come from recombinant DNA-based biologicals. Now, the biologicals are excellent drugs because they are very specific. Specificity is very high. Sensitivity is also high. But they are highly personalized, and you need some early diagnosis to find out whether the drug is going to work for you or not. Plus the fact that all biologicals are extremely expensive and unaffordable. The average cost of a new biological-based, biotechnology-based drug is approximately $50,000 per treatment cost, with something like Sovaldi, which is for hepatitis C, being charged $84,000 for treatment. So personalized medicine is a good thing, but the developing countries really need mass treatment rather than personalized treatment, because personalized treatment is going to be extremely expensive for people like us.
No, I would say it's really fascinating to think about the information that needs to be brought together in terms of profiling the patients to know what the best strategy is. So advances in rapid diagnostics, as Dr. Banerjee suggested, are essential in order to allow the implementation of any specific strategy rather than an empiric broad spectrum strategy for an individual patient. And that will probably have to move away from culture-based diagnostics to nucleic acid or immunodiagnostics that are coupled with new technologies in terms of maybe microfluidics or machine learning that can spot the patterns in the organisms. We indeed have been able to accelerate, for example, with gas chromatography, patterns that are specific for pathogens that predate by several hours the yield of a culture in a BACTEC system. And these can be refined using DNA melt patterns coupled to real-time PCRs and other method. A San Diego company called Illumina just announced that they envision a $100 1-hour complete human genome sequence in the next several years, which would make that an opportunity. The problem is that the effort and data accumulation and the low cost where tremendous advances are being made are not matched by the systems biology and analysis to extract the information from that data. Somebody did a systems biology analysis on how much systems biology you need for relative genetic genome acquisition and pure sequencing. Right now, about 95% of the costs and research efforts are in accumulating sequences, the vast majority of which don't get fully analyzed. But really, you should probably be spending about 5 or 10% of your money on the sequence and 90% on the analysis to identify patterns that can be the basis for future therapies. We had a discussion over lunch, for example, about certain antibiotics that are fantastic in terms of their spectrum and efficacy and pharmacodynamics, like chloramphenicol, which are still used in India for specific indications, but in America it's completely banned to use this in a routine basis because of very rare complications of bone marrow suppression and aplastic anemia. But there probably is an immunogenetic predisposition to have that, and these people are still around who experience successful treatment outcomes versus the rare complication. We might be able to use genome sequencing and other approaches, positional cloning and systems analysis, to determine risk factors, as we have done, for example, for aminoglycosides and ototoxicity and hearing loss, to allow us to recover a lot of antibiotics that have idiosyncratic toxicities, but may in fact be beneficial for the majority of patients if we can exclude them from being in the high-risk group for toxicity.
I have two rapid fire questions for two of my panelists before I open it up for more questions. Dr. Anirban, your thought process on where are we with respect to the inflection point for immunotherapy? We spoke about it this morning, fantastic talk from both of you. I mean, I work on small molecules, but I'm so fascinated by non-chemical, non-standard pharma methods for antibiotics. So in your opinion, how far away from the inflection point are we in this whole immune therapy area before the markets, before financiers, etc., take it seriously?
Well, I guess first of all we have to come out of this denial mode, because we have been long enough hiding ourselves into that before, in this denial mode, that there's some isolated cases here and there which may spring up and show us that there are some antibiotic resistance somewhere, something happening over there, but there's not a whole gamut of cases. So I guess the first thing that we need to do as an international community, particularly in a country like India, where we have to come out of this denial mode and get into an acknowledgement mode where we agree that this is a problem, this is a serious issue which we need to tackle. And once we get into that mode, then comes the challenges ahead in terms of like how to tackle these problems, because honestly speaking, we are just seeing the tip of the iceberg. As of we speak, and as Professor Nizay said in the morning, we are multiplying in once in 30 years or once in 40 years, and these guys are multiplying once in 20 minutes. So they are way ahead than us in terms of even thinking and in terms of even multiplying. So as of we are speaking, they are probably doing something and getting more antibiotic resistance than we can possibly think of developing in the next few years or so. So not only one approach of developing new molecules, that is of course going to be one of the approaches, but apart from that, some unconventional approaches, thinking out of the box, like as Professor Nizay in the morning said, in terms of like boosting your own immune system. I also showed something about in terms of like boosting your cellular immunity, in terms of like the intracellular immunity. Can we do something on those regards? But it's still premature, and as I said, I'll give you a glimmer of hope in this. Ebola was there for quite some time. Quite some time it was there. There have been sporadic cases of epidemics of Ebola in Africa and all that, but it was not until last year or 2015 when it started, that pan epidemics, and few thousand people started dying out there. Then the world community suddenly woke up and said, like, we need to do something about this. And suddenly there was this, vaccine against Ebola was developed, and now it's like, you can have the vaccines of Ebola. Similarly with Zika. We have never had any idea there's something called Zika actually exists, and it was there in Brazil for quite some time. So suddenly there was this Olympics, and then there was this fear that several hundred people will go over there and get infected, and they will bring these cases back into their home countries and all that. All these things, the international community has to wake up, and once they wake up, I'm sure we as a human and with our intellectual capabilities, we can do wonders, I would say.
Excellent input. The international community has woken up, and whether it's WHO or the BARDA, Wellcome Trust, UK government, DBT, lots of people are taking this very seriously, and you'll see more dollars coming into R&D for diagnostics, for software applications, data analytics in the space, as well as for discovery. Question for you, Jeff, before we open it up to the audience. I'm moving away from AMR to a little more ecosystem-oriented question for you youngsters, particularly who are thinking about doing startups, etc. So Jeff, you worked in Scripps, one of the top ecosystems in the world for innovation, and now you're in UC Riverside doing great work. I also understand that you're doing some interesting work in technology transfer between academia and industry. We as a country are pretty backward in that, right? Folks like Dr. Bipin are actually an aberration. They've done a fantastic job going out, talking to industries, connecting with industries. And I mean this, very candidly. But the general population, academics, interacting with industry is very poor. I'd like you to share for us, how do these ecosystems, so Scripps or Riverside, how do these ecosystems, how are they so vibrant? And what are you doing in the tech transfer, for example, that we can learn of, that can enable much better interaction between industry and academia?
Thank you. Yes, it's a really good point, and for me, it's very exciting. Try and spin stuff from the bench out into the clinic. I would say that actually I've always had a sort of industrial links. My undergraduate, I went and worked for Glaxo Wellcome. I think I was the first undergraduate to do that, and now they give a master's degree for doing that. They didn't give me one. I was, I started it, and then I went to when I went to Cambridge and did my PhD. Pfizer actually co-sponsored me, so I had normal fellowship and then also Pfizer on top of that. And I was working on one of the breaks for the immune system. But now I suddenly realized, listening to Victor's talk, actually maybe it could be a novel therapeutic target for, so we can chat some more, maybe get some ideas. And then, so moving to Scripps, and certainly the same with UCSD, and perhaps can I be bold enough to ask some of the other panelists to make a comment as well? Because I know Victor's got experience, and I was very curious about what it's like in India in terms of startup space. But I can tell you what it's like from my experiences. So I'm currently co-founding 2 companies, one for a novel therapeutic target. We have lead compounds for Parkinson's disease that we're very excited about, something we've been developing for the last couple of years. And there's a second one for selective targeting of p53 null cancer cells as well. And so I still have much to learn. But one of the reasons why I remained in Southern California was that I had options to go elsewhere to take a tenure track position, but I took the Riverside one was because I wanted to be actually in that ecosystem. And as Dr. Nizay pointed out in his talk, there's 500 plus biotech companies in San Diego, startups. So it's a wonderful ecosystem, and they are often, certainly in the small and medium scale biotech companies, they're very focused on the technology they have, but it doesn't answer all the questions they need. So it's nice that you can come in and start collaborating with them and sort of working together. So that's the one encouraging point. And then the second point, there is actual governmental support. There's a specific grant funding program, SBIR or STTR funding. And I'm curious about what there is in India, if they have anything like that, because there's a whole second pool of money for me. I can get an academic grant. If I get some interesting results, I can go and apply for that STTR grant and actually get money, and half the money, if I write one of these grants, goes to my academic lab, and then the other half will go to the company, but it could actually be a company that I founded. So really I'm getting 100% of the money, and I'm just doing half my academic research and maybe having my startup do the animal models or something like that. And then on top of that, actually, I'm sort of finding with the UC system, we're having good experiences with the tech transfer. I know at UCR, actually, they're sort of building their own VC fund. So that actually they may actually give you startup monies for yourself to help you launch out as well. So that's my points.
Would any of you like to comment on the Indian scenario?
I just have some recommendation to the academic drug discovery groups in India. The global R&D spending is approximately $85 billion. The Indian R&D spending in the industry is approximately $1.5 billion. The government spends about $1 billion. So total spending on drug discovery R&D is $2.5 billion against a global spending of $85 billion. Now the largest, topmost 10 pharmaceutical companies in the world spend anywhere from $4.5 billion to $10.5 billion a year. So our entire Indian pharmaceutical industry's R&D spend is less than the 10th company in the world spending on R&D. So the Western model of drug discovery R&D is not on as far as India is concerned. We never can find the resources, we cannot find the infrastructure, we cannot find the skills. Then what do we do? My proposal is all the people including people like Amrita, for example, should look at the new example of repurposing the existing molecules. Look at the existing molecules, look at their mechanisms of action, look at the side reactions. Very often a side reaction becomes a major indication from the point of view of drug discovery and development. So we should have a paradigm shift from following the Western model of drug development into looking at repositioning, repurposing of drugs for indications for which there's an acute medical need, particularly in developing countries, not only in India. There should be identify the therapeutic area, identify the molecules which has a potential to be considered, prepare a roadmap for that, and let us present it to the government saying that this should be a national program of repurposing of existing molecules.
Excellent report. Dr. Anirban, do you want to dovetail from what Jeff left off? What's happening in our ecosystem here?
Well, in the governmental wise, DBT has this BIOCREST setup, which is now helping the new investigators or existing investigators also to set up companies on. In IIT Bombay, we actually have a center called Sign, which actually allows you to incubate your companies. If at all you have some ideas of business, you have some not only lead compounds, but maybe some technology or something like that, some portable devices making prototypes and all that, and you want to make it, market it and all that, you can actually incubate some companies over there, and the institution supports it until and unless you can actually stand on your own legs. So I think those are nice initiatives, and earlier very few individuals used to take these actions and used to take these steps in these directions in order to follow that. But nowadays there are a lot of individuals. In fact, I know a couple of individuals from our couple of faculty members from our own department who has done that. There is Professor Debjani Paul, who is a relatively very young investigator, just a similar age of mine. She has recently developed a cell phone-based camera, cell phone-based microscope by which you can actually detect sickle cell anemia. And that she has been giving this cell phone, and it's already in the market, and they are putting these cell phones into the people where there are like sickle cell problems are there in Gujarat primarily, and they are showing fantastic results in terms of like.
Thanks very much, Dr. Bipin. Would we have time for one or two questions? It's bang just about 3:30, and is that okay? With your permission, sir. Yes, please.
So, as in any crisis, a kind of a blame game is all over. So we've been blaming the pharmaceutical company. We've been blaming the waste, the way in which the wastewater is treated, and so on. I'm trying to detach myself a little bit from the research arena and ask a question back to you. Whether the research group as such is kind of booted up rightly to find different other strategies in order to counter this particular issue. An additional question to that, because in the morning kind of talk of Dr. Nise, he was talking about improving the immune response, and probably that particular strategy is quite running parallel to the traditional strategy of Ayurveda and so on. I'm not arguing that probably those people knew the strategy earlier on, but the point is that we have been forced to explore those kind of strategies as well. Are we really opening up to such kind of opinions which are not quite rational, and finding out-of-the-box solutions to this crisis?
Let me give my 30 seconds and then open it up to my panel. I can tell you in India there are 4, including mine, that are looking at novel solutions for AMR. That means novel antibiotics. Not just taking an old antibiotic and finding 5th generation, 6th generation. Novel mechanisms, single target, multi-target, etc. I don't know anyone, though, in India working on immune therapy. I do know groups that are now looking at microbiome, but at a very fundamental level, it's going to take a long time to come out. You have to appreciate that in India, we have a nightmare of a regulatory climate. They even look at small molecules with, very stringent guidelines and sometimes ridiculous guidelines, let alone bringing out new things like poop or other things, right? It's going to take time. So those are going through fundamental science level, and they have to reach a translation level before you are going to hear about it. But there are at least 4 companies looking at novel solutions. I know a bunch of companies that are working on diagnostics that could potentially be funded by Wellcome Trust, Longitudinal Prize, etc. So it's really not all gloom and doom. I see software people coming in saying, let's look at data analytics to find out if certain part of India is more prone to carbapenem resistance, right? I see people from electronics, electromechanical background coming to build devices for point of care, for affordable TB kits to do MDR. So that it's happening in layers. But I'm going to let my panel talk about the completely out of the box solutions if they know of anything happening here. But trust me, this panel was just not about complaining, right? The fact is so many islands of excellence are coming together, but it takes time. There is no short-term solution. Probably the shortest term solution is stewardship. Shortest term solution is stewardship, responsible behavior by all of us, followed by diagnostics, because that is the shortest lead to the market. Therapy takes the longest time. Whether you use immune therapy or small molecules, it's going to take 5-7 years. That is the nature of the beast. You can't do much. But things are happening piece by piece, right? But any other opinions from my panel on this?
Well, I think many of you might recognize that certainly a large proportion of new FDA drug approvals in our country are biologics now rather than novel small molecules, and they have accelerated pathways both in development and approval, and the largest chunk of those are targeted monoclonal antibody therapeutics. And it's interesting that that has been absent from the field of acute infectious disease therapy as well, mainly because of a tradition that infectious disease therapy, even of the severe life-threatening infections and hospitalized patients, should be inexpensive. In America, you know, a cancer therapy can cost many tens of thousands of dollars, but antibiotic therapies, somehow by tradition and acclamation, should cost only a few $100s. So that has, but I can tell you, in working with quite a number of companies, there are excellent opportunities, especially for these kind of rare nosocomial infections that people don't happen to have. You know, most of us will not have antibodies against Acinetobacter baumannii. It doesn't really live too much on the human body. It's present in the soil, but if you get sick and in a hospital for a long time and have catheters in place or a weakened immune system, it can establish infection in your body, and maybe targeted antibodies against this and Pseudomonas and Klebsiella and strains of E. coli might be available. They could also be broad spectrum and target many gram-negatives because they're going to be administered systemically for severe infections and not have effects on the normal flora. A second area which I think is really interesting and many people might not realize is that all of us right now have very high titers of antibodies against certain carbohydrate epitopes, like the alpha-gal epitope and anti-Ra epitopes. These are sugars that have been lost in humans through evolution, but are still present in other animals and microbes. And through eating meat or exposure to the microbes, we develop antibodies against them. And why they reach ridiculously high titers is unknown, but they were discovered in the course of xenotransplantation, when you try to introduce a pig heart into a human, which is just the right size, it's immediately rejected by these antibodies. But people have been thinking, if you have all these pre-existing antibodies that target these glycan epitopes in your body, what if you just made a drug that on one end bound to the antibiotic-resistant pathogen, and on the other end presented the epitope to your natural antibodies? These drugs, which would be small molecules, let's say they have callistin on one end, or another binding moiety that targets the pathogen, and then presents the epitope, you could become instantly immune with your pre-existing antibodies and clear the pathogens. And I think that's another area. So targeted antibodies or engineered molecules to recruit pre-existing antibodies are exciting areas.
Very exciting input. Clearly, even a great learning for me to look at innate immune systems role in helping with infection. I think we have time just for one last question. Now students wake up. Let me see. Who put the hand most? Sorry, ladies first. Young lady right there. Yes, ma'am.
Good evening, respected sir. I am Aditya Pillai, MSc Microbiology student. Sir, I just want to know that our respected panel has thrown light on the topic of stewardship. But as a microbiologist, what all are the strategies which we can implement to get a better stewardship in hospital? For example, like Dr. Victor told that hand washing. It is something that all the medical workers are doing. But like other than that, for example, microbiologists, we are doing sterilization, disinfection, all that things. And stewardship is something doing things properly or supervising things properly. So what are all the new techniques or strategies which we have to implement in this sector to gain a better stewardship?
The man who can answer it is right here.
Yeah. It's a very valid question. How can a benchtop microbiology make a difference in the clinical prescription pattern? That's what the question is.
Yes.
Now, do you know what the physician treats? The physician doesn't treat the patient. He actually treats the microbiology report. My lab processes something around 450 samples per day. We grow something around 40,000-50,000 bacteria per year. Sit, please sit. So if you give the right report, the back of sensitivity by doing the right method, by testing the right antibiotics, by reporting the relevant antibiotics. If you go to another lab, the antibiotic susceptibility would be of 15 or 20 drugs for Staph aureus. If you come to my lab, I'll give you 6 antibiotics, not more than that. So testing methodology is very important. Reporting an antibiotic for a relevant pathogen, that is very important. So doing your microbiology, getting it right is first thing. The physician doesn't know much about microbiology, susceptibility testing or antibiotics. So if you give the wrong antibiotic, wrong susceptibility, there itself the whole stewardship is gone. The physician is misled and the physician will treat him wrongly. So do your job first properly in the microbiology lab, follow the guidelines, get it right there. And report only relevant pathogens. Now physician will send anything. In my lab, anything comes in, believe me, I will grow something and give it to you. That's my job. But that doesn't mean it is a pathogen. So always tell them, don't treat the microbiology report, treat the patient. In my hospital, almost 80% of the colleagues call me and ask me what to do about it. Now, we are a very big hospital and we do a lot of testing. So I get exotic organisms, that boss had told us. Exotic means something like Elizabeth Kingia meningosepticum. So the physicians don't have an idea what it is. So once my physician asked me, Anil, you've grown Elizabeth today. When is Charles coming? So my advice to them is, if you find it difficult to pronounce a bacteria, it's bad. It's multi-drug resistance. And it may not be a pathogen also, it could be a colonizer. So they get in touch with me, they call me. In my hospital, I talk to the clinicians. That's how you increase stewardship with the physician. The physician has to call you. No physician will take your advice lightly. He thinks he knows everything. It's a physician who has to call you. And for that, you have to do things right so that he develops confidence in your report. Then only he'll call you. Microbiologists are the infection control officer in the hospital. So they take care of the infection control protocols. They make sure the hand hygiene, you said hand hygiene, everybody does it. That you think they do it. It's abysmally low. It's something around 30-40%. Hand hygiene compliance. Now just rubbing something between the palm is not hand hygiene. There are 5 steps that you have to follow. And 5 moments. So those moments has to be taken care of, those steps has to be taken care of, then only hand hygiene is complete. Just rubbing something is not hand hygiene. I do hand hygiene audit in my hospital, I know how bad it is. So microbiologist is the backbone. If you do your things right, you can get many things right at the clinician's end. Our hospital has got an antibiotic policy. Our hospital does antibiotic stewardship. We audit high-end antibiotics. And our hospital has got an app for treatment of different conditions. It's available to all our doctors. They can log into the app and find out what is the drug resistance pattern in last year for the E. coli or Klebsiella, and think an appropriate antibiotic that the app will also tell you, and that antibiotic can be used. This is a recently launched app. I think Dr. Sanjeev Singh will tomorrow speak on all these aspects. We are very proactive in antibiotic stewardship, and microbiologist is a very important part of that stewardship program.
Thank you so much. Excellent inputs and very positive inputs, right? Give him a huge round of applause. Very positive. Very few hospitals can claim this, and I really, really appreciate that. And Dr. Bipin, if you could make that app available to the larger community, it will really help other hospitals too. Doc? Okay, we have to wrap up this wonderful program. I know there are many more questions, but we are running out of time. Dr. Bipin and I will discuss which was the best question and get back to the person for the prize. I really want to thank you all. Fantastic audience and an outstanding panel. I'm going to give it to Dr. Bipin to give the closing comments. Sir.
So before you, there were at least 8 or 10 hands that were up from the students for questions. We would have liked the panel to respond to those questions, but paucity of time. Anyway, I just want to take this opportunity to thank all the panelists for this excellent session, and I'm sure all of you enjoyed the interaction. Thank you once again.